The Earth is also known as the water planet. Although 1.4 billion cubic kilometers of water exists on the Earth, only 0.01% of it can be used by people. But there are still rich natural waterfront environments around us. One of Fuji Clean's missions is to maintain this beautiful waterfront environment for our children. Fuji Clean conducts research and development of advanced wastewater treatment systems through 50 sales offices, 3 factories, and 1 research laboratory in Japan. R&D for wastewater treatment systems focuses on themes such as a smaller footprint, advanced performance, and energy conservation. In order to achieve these goals, we produce high-quality, high-performance products developed by our prestigious engineers and many proven proprietary technologies. Our mission is also to keep producing reliable and cutting-edge products, thus leading to the conservation of water environments in the future. The CE model is an advanced next-generation system. Proper maintenance is essential for stable performance of the system. We will now introduce the structure of the CE model. First, wastewater goes into the first chamber, which is called the sedimentation chamber. Flow opening for the CE model is positioned at intermediate water depth, resulting in horizontal water flow. This prevents accumulated sludge at the bottom of sedimentation chamber during peak flow. In the anaerobic chamber, anaerobic bacteria decompose nitrogen oxides into nitrogen gas. We have also adapted upflow to the CE model. This makes it more effective to remove suspended solids by using the 2 functions of settling and filtering. In the aerobic chamber, water flows through 2 different types of plastic media for decomposition and removal of organic matter and suspended solids. At the same time, ammonia and nitrogen is removed during the nitrification process. Treated water flows to the storage chamber, is transferred to the disinfection chamber for sterilization by the airlift control unit, and is then discharged. The CE model has a simple peak cut function for large amounts of incoming water. This allows the water level to be fluctuated by 50 millimeters. Please conduct maintenance service before first usage, and once every 4 months afterwards. Also, desludging is required at least once a year. Check for odors, bugs, vibration, noise, and foreign objects. Also check the inspection opening for foreign objects. When an odor exists, or the transparency of treated water is 20 centimeters or less, measure the water temperature, transparency, potential of hydrogen, and oxygen demand for each chamber. Next, inspect each chamber. When inspecting the sedimentation and anaerobic chambers, check for abnormal increases in the water level, scum growing, gas generating, and accumulated sludge. For the aerobic chamber, check for abnormal increases in the water level, aeration, and foam formation. Also check the recirculation flow and disinfectant tablet. If you find a large amount of scum and accumulated sludge, transfer them to the sedimentation chamber. A short pass in the anaerobic chamber may result from conditions such as a high concentration of suspended solids. In such cases, degas by pricking the filtration media lightly with a pipe. If there are no bubbles in the aeration chamber, or bubbles come up unequally, check the air leakage of the aeration pipe, inspect the blower, clean inside of the aeration pipe, and adjust the aeration valve. Please conduct backwash during every inspection to the aerobic chamber. First, set the effluent valve to 0. Set the recirculation valve to 70 to 80% and return the accumulated sludge from the bottom. After 1 minute, return the recirculation valve to its original position. As long as the returned water is still dark, continue to return water to the sedimentation chamber. Rotate the aeration valve to the right 100%. Conduct backwash for approximately 1 minute. Rotate the aeration valve in the opposite direction to 100%. Conduct backwash for approximately 1 minute. Return the aeration valve to the original position. Set the recirculation valve to 70 to 80%. After 1 minute, return the recirculation valve to the original position. Repeat this series of valve operations. The media has high trapping performance, and a single backwash is not enough to wash away biofilm from the media. Therefore, multiple backwashes are more efficient to detach biofilm and make them fall down to the bottom. Also, it is more efficient to conduct the multiple sludge returning operation, rather than the single long operation. This is because the biofilm will be easily washed away and will fall to the bottom, and the biofilm will be pumped up by the airlift control unit. Please note that the backwash and sludge returning are one series of operations. After finishing the backwash operation, return the effluent valve to the original position. Check the status of aeration. Check the recirculation water flow rate at the outlet of the recirculation pipe after adjusting water flow rate under the standard line. Before measuring the recirculation flow rate, please ensure that the water level is at the lowest level. Rotate the recirculation valve to adjust the recirculation flow rate. Also, ensure that the water level is at the lowest level. The water level may rise to a maximum of 50 millimeters from the lowest level. The recirculation flow rate will increase if the water level is high. Before measuring the recirculation flow, discharge more effluent water by adjusting the effluent flow rate to 70 to 80% until the water level decreases to the low water level. When the water level reaches the low water level, return the effluent valve to the original position. When the pumping discharging rate does not increase, try cleaning inside the effluent airlift pipe. When the recirculation rate does not reach the correct flow, try cleaning inside the recirculation airlift pipe and recirculation pipe. When you find unequal aeration, try cleaning inside the aeration pipe. For pressure water cleaning, prepare a vinyl hose and a short pipe of 13 millimeters in length. Connect the hose and pipe together, and then directly connect them to the union of the aeration pipe. The aeration pipe can also be cleaned by inserting a pipe cleaner inside the aeration pipe. When foam forming occurs over the partition in the anaerobic chamber, the biotreatment process may not be activated sufficiently. In this case, put seeding material to the anaerobic chamber. If scum is found in the storage chamber, transfer the sludge to the sedimentation chamber. Also, if you find enlarged biofilm on the wall of tank, remove all biofilm and clean the tank. If you find accumulated sludge in the storage cleaner, ensure that the recirculation airlift control is functioning properly and transfer the sludge to the sedimentation chamber. If no water is pumped up even though the water level is not at the low line, clear any clogs in the effluent airlift pipe and effluent valve. Clogs in the effluent valve can be cleared by opening and closing the valve several times. To prevent the effluent valve from clogging, we recommend opening and closing the effluent valve during every inspection. Please ask the homeowner to contact the maintenance service provider when the indication light of the power plug is flashing. Prompt action will prevent further complaints regarding odor or other problems. In this case, replace the diaphragm parts kit and set the auto stopper piece in order to restart the blower operation. When desludging, make sure to first pump out scum from the anaerobic chamber and then pump out from the bottom. There are flow openings under the water level, so the water level of the second chamber decreases simultaneously when pumping out from the first chamber. Therefore, clogging may occur if the scum gets into the anaerobic media. In order to prevent clogging during the desludging, pump out scum in the anaerobic chamber. Appropriate maintenance and operation is essential to ensure the best performance of the FUJICLEAN treatment system.